So now we're going to continue this with the last lesson. The horizontal shifts H and the vertical shift K are called translations or shifts. But now we're going to try to multiply the whole function by a number. For example, A times f of x. So just like before, I have that x and f of x are here, and it just give me those points that represent this graph here. So now I'm going to take these points and I'm going to multiply it by a 3 to kind of see what I get. This first one here, I have 3 times 0, which is 3. Then I have 3 times negative 2, which is a negative 6. 3 times 0, 3 times 2, and 3 times 1. So I'm going to plot these points, and my points would be 0, 3, 2, negative 6, 4, 0, negative 2, 6, 5, 1. Here's what you would get, but I actually made a few mistakes, or 2 mistakes. This would be 0 here, because 3 times 0 is 0. This would be a 3, because 3 times 1 is 3. So notice that because I had a 3 there, it started to kind of stretch. It went from being a short graph here to being something super long. Let's try the next one. H of x equals 1/2 of the values I had. So I would get 1/2 times 0, 1/2 times negative 2, 1/2 times 0, 1/2 times 2, and 1/2 times 1. This would give me 0, negative 1, 0, 1, and 1/2. Let me go ahead and plot those points. This time it was actually compressed. Think about smashing it down to make it smaller, because it's going to be half the size. Let me go ahead and label these before I move on to the next one. So when it's g of x, this means it was stretched vertically by 3, meaning by a factor of 3. The next one was compressed vertically by a factor of 1/2. Now let's look at the last one. In this last one here, I'm taking my values and I'm multiplying it by negative 1. So 0 times negative 1 is just 0, negative 2 times negative 1 is 2, 0 times negative 1 is 0, 2 times negative 1 is a negative 2, and 1 times negative 1 is negative 1. Once again, all of these values are coming from f of x, which is this column here. I'm going to plot those points and kind of see what it gives me. So it's kind of just the opposite. What we're going to say is it's going to be reflected. So we're going to call this a reflection across the x-axis. So now that we know these, we need to write a function to show that f of x was stretched vertically by 3/2. All we're taking is, let's just say that this is going to be j of x. Let's say that we have f of x, and by 3/2 would make that times 3 over 2. Now for kind of our rules here. A times f of x, where A is your vertical stretch factor. It's the number you're going to be multiplying it by to make it stretch vertically. If A is greater than 1, it is going to be stretched vertically. If A is between 0 and 1, it is going to be compressed. And if A is less than 0, it's going to be which means a negative a, it's going to be reflected across the x-axis. Now let's say, for example, I had that my a was a -2. That would mean it's going to be stretched and reflected. So it could be both. If I had that a was a -1/2, then it would be reflected and compressed. So those factors still apply. So based on the horizontal translation above, it seems that we can make a horizontal change by making changes to the x value of the original function. However, this semester we're only going to be focusing on if your b was a negative or a positive. We won't make you do stretch or compress along the x-axis. It's going to just be, is it reflected or not? So in this case here, reflection over the y-axis. So all I'm going to do is take these values here and multiply it by -1. So it ends up becoming 1, 0, -1, -3. If I plot those points, here's what I get. Guys, all we do is kind of flip it. We took these points and we're like, okay, if it's here, we're going to just kind of move it this way. This one moved to here, and this one moved to here. So that's what we call a reflection. So f of 1f to the -x would just be reflected across the y-axis. So f of b to the x is a horizontal reflection. -b means reflects horizontally across the y-axis. The next section says, describe how the graph of g of x equals -2 times f of -1, x plus 1 minus 10 is different from f of x. We just have to describe the transformations that are occurring in each step. So let's start with this one here. That number in back represents k. So if k is a -10, that means it's going to be shifted down 10. Let's take a look at this number here. Since it's a positive one, that means that my h was actually a -1. Therefore, it's going to be shift left 1. We just finished talking about this one here. That is going to move, my b is a -1. Therefore, it was reflected horizontally and one more is this -2. That means that my a is a -2. Since it's 2, it's going to be stretched vertically, but it's negative, that also means reflect across the x-axis, or reflect vertically. And the last one says the function f of x is shown as a solid black line. Find the equation of the dotted line g of x in terms of f of x. Which means we need to find out how to make this dotted line into the black line, or the black line into the dotted line. So by looking at it, I know that they're very similar and it doesn't stretch at all. And I can kind of look at these pieces here. I know that if I went down 4, it's on the opposite side of the y-axis, meaning all I need from here would have been to reflect it. So the pieces that occurred were a shift down 4, which refers to a k being a -4, and it reflected across the y-axis, which means a negative b value. Therefore, g of x equals f of negative 1x minus 4. All I did was say that I plugged in the pieces I needed into here.